Hello, this is my experiment F video for my unknown number 210 and how I determined the structure of it. So first, I solved for the molecular formula to get a base idea. So I used the molecular weight given, which was 120, and then I did the rule of 13, and I got the formula C9H12, and then afterwards I solved for the HDI, and I got HDI of 4, and I know from the notes that if the HDI is 4 or greater, then there's usually an aromatic or benzene ring. So that was kind of what my base was. So then I moved on to the IR, and from the IR there are like 3 main peaks that stood out to me. So the first one was the peak at 1701.5, and I know that a peak around 1700 usually indicates a carbonyl compound, so I kept note of that. And then there's also a peak around 1600 that was pretty strong, and I know that usually indicates the aromatic ring, which kind of matches with the HDI. So then afterwards I looked at other peaks to find out what carbonyl compound it could be, and I saw these two weak peaks at 2825.3 and 2730.3, and I know that when there's 2 peaks around 2700 and one at 2800, it could be an aldehyde, so I kept note of that too. So from the IR I found that it could be an aldehyde and an aromatic ring, and there's no OH or NH because I didn't see any peaks or broad peaks past like 3000 or around 3300. So then afterwards I moved to the NMR. So then first I looked at the ppm of the peaks, or I know there's 4 main peaks too. So the first one was the peak around 10 ppm, and I know that a peak around 10 ppm usually indicates an aldehyde, and that matches with what I determined in the IR, so there should be an aldehyde in my structure. That's why I concluded. And then there's 2 peaks at around 7.8ish and 7.3ish, and that does indicate a benzene ring too, so it also matches what I said on the IR and from the HDI. And then the peak around 2.5 could be a lot of things, so I just kept that to the side for a little bit. So then now that I knew that there should be an aldehyde in my structure, I added oxygen to my formula because I knew there has to be an oxygen now. So from the notes of the rule 13, I know that an oxygen is equivalent to a CH4, so I subtracted a CH4 from the molecular formula that I previously calculated, then added an oxygen, and then I got the formula C8H8O. And I solved for the HDI again, and I got HDI 5. So again, it's above 4, so there still should be the aromatic ring. So then after that, I basically solved for the structure using the basic stuff. So again, I wrote down the ppm, and then I measured the height because they didn't give me the integration for each individual peak. It kind of spread out, so I solved for the height of each peak, which gave me 2 centimeters, 4 centimeters, 4.5 centimeters, and 7 centimeters. And then I solved for a number of hydrogens, and I know there should be 8 hydrogens in total, so there should be 1 hydrogen for the peak at 10 ppm, and then 2 hydrogens for the peaks around 7.8 and 7.3, and then the peak at 2.5 should have 3 hydrogens because I had the highest height. So then that equals 8 hydrogens total. And then again, include there's an aldehyde around because it's around ppm of 10. And then it's also a singlet from the other NMR that I gave up of the close-up view of it. It's a singlet, so I know that it has 0 neighbors. And for the aromatic ring, it was two doublets. Again, from the close-up view, we can see two doublets. So, two doublets would indicate a para benzene ring. So I put the para, and then they should have one neighbor each. And then for the peak at 2.5 ppm, again, I just put a CH3 because it has 3 hydrogens. And it's a singlet also. As you look closely, it's kind of hard to see, but it's a singlet. And then the number of neighbors would be 0. So I knew that was a para aromatic ring. And then there's aldehyde and CH3, so I just added it basically to get this structure, which is a 4-methyl benzaldehyde. And then I just checked with the formula, which was C8H8O, to make sure that everything matched up. So first I checked the hydrogens, so there's 1 hydrogen on the aldehyde, and then there's 4 hydrogens on the aromatic ring, or the benzene ring, and then there's 3 hydrogens from the CH3. So in total there will be 1, 2, 3, 4, 5, 6, 7, 8, so that matched. And then I counted the carbons. So again, there's 1 carbon on the aldehyde, and then there'll be a carbon here, 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 here. 1 for CH3, so in total there's 8. 1, 2, 3, 4, 5, 6, 7, 8, yeah. So that matches again, and then there you have the 1 oxygen from the aldehyde. So it matched with the formula, the molecular formula that I got. So yeah, so that's how I basically determined my structure as 4-methyl benzaldehyde from my IR and NMR graphs. Yeah.